In this video, we're going to be talking about factoring when there are 4 terms and how we approach factoring like this. So when I first look at this, I should always be looking for GCF, but when I look at it, they don't have any coefficients in common, any common factors there. They don't all have variables, and so I might think that there's nothing I can do. But when we have 4 terms, we can actually try factoring by grouping. So I'm going to group these to start. I'm going to start by grouping these 2 terms and those 2 terms. After I've grouped them, I want to find the GCF of each group individually. So looking at this first group here, the GCF would be y. They both have a y in common. They don't have any coefficients in common, but they both have a y. I do the same thing over here. I look for the GCF of the second group. So GCF of the second group would be 3, right? So they don't both have x's, but they do both have a 3 in common. Once I find the GCF of each group, I factor it out. So I divide it out of each term. So divide by y, divide by y, divide by 3, divide by 3. And then I write it in the factored form. So the y was the GCF of the first group. When I divide it out, I'm left with x minus 5. I do the same thing with the second group. So I factored out a positive 3. And when I divide out a 3, I'm left with x. And 15 divided by 3 is 5. And there's still that subtraction in the middle. Once I've factored out the GCF from each group, remember different GCFs are possible, I look at what's left. And if I did it right, then they should match. I notice here that the common factor now is that whole expression x minus 5. Right? Factors are things being multiplied, and they both have an x minus 5 in common. So now I'm going to factor out an x minus 5. Again, they have to be identical. And to write it in my factored form, I have that GCF, which was x minus 5, times what's left when I divide it out. So this is gone, I only have a y, that's gone, and I have a positive 3. And now this is completely factored. So that's going to be the approach. We group them, so 2 terms and 2 terms, find the GCF of each group individually, divide it out, write it in its factored form. If I did it right, I should find an expression in common, divide that common factor out, write the GCF of that same expression, times what's left when I divided it out. Now, I can always check myself, right? So I have 2 terms being multiplied by 2 terms. I could FOIL, I could use the box method, but I could multiply this whole thing out, and I need to get what I started with. So you can always check your work, right? Factoring is undoing multiplication. So this is the multiplication. If you multiply that all out, you should get here. Factoring undoes that and gets us back where we started. Let's look at another one. Same thing, I'm going to start by grouping them. So I'm going to group it. I'm going to look for a GCF in each group. I notice that these both have an a squared. No b's in common. The second group, I see that the leading term has a negative. So I'm going to go ahead and take out that negative along with a 3. They both have a 3 in common. I'm going to factor that out of each one. So I kind of wrote that close, so I'm going to write it up here. Dividing out an a squared from each term. And same thing with the second group. I'm dividing out a negative 3. I'm looking at what's left. So the a squareds divide out. I'm left with b squared. And anything divided by itself is 1. You need to not forget to multiply by the GCF. So that's the factored form of the first group. Second group, I pulled out a -3. That was the GCF. What's left? Well, 3 divided by 3 is 1. And I have the b squared, right? Negative, negative made it positive b squared. And -3 divided by -3 is positive 1. Anything divided by itself is 1. If I did it right, then I should see these matching factors now. B squared plus 1. So that's my new GCF. B squared plus 1. I'm going to factor that out. And what's left when I factor it out would be a squared minus 3. Right? If I divide this out, it'd be gone. This would be gone. I'd be left with a squared minus 3. And so there is my factored form. Go ahead and try the 2 on the right. Alright, we're looking at this example. Y cubed plus 6y squared plus 4y plus 24. I'm going to start by grouping my terms into groups of 2. I look at the GCF for each group. I notice that the first group has a y squared in common, no coefficients in common, no numbers. The second group has a 4 in common. So this one doesn't have any y's, but they both have a factor of 4 in common. I'm going to go ahead and factor that out. So y squared is coming out. When I divide it from y cubed, I'd be left with y. When I divide it from 6y squared, the y squareds divide out, and I'd be left with 6. So again, you could write out more steps if you wanted. You could fill in this showing the division. But I feel like I showed it over here, so we're just going to jump right into the factored form. So again, start with the GCF, and what's left when you factor it out? 4y divided by 4 would just be y, and 24 divided by 4 would be 6. If I did it right, then I'll see I have, I'll see that I have these two terms in common. Sorry. And I will divide out that GCF of y plus 6. What's left when I divide those out would be a y squared plus 4. Right? Divide this out. Anything divided by itself is 1. I'll be left with the y squared. Divide this out, and I'll be left with 4. Not forgetting my GCF, which was that y plus 6, times what was left when I divided it out. And that is the factored form. Let's look at one more down here. I'm going to go ahead and start by grouping the first two terms. I notice they both have an a in common, no coefficient and no b. The second group, I notice that that leading term has a negative, so I'm going to go ahead and take a -1 out. And then they don't have any b's or any other constants in common. So I factor out an a from the first group. ab divided by a is just b. 5a divided by a is just 5. Then I took out a -1, so I'm left with -b divided by -1 would be positive b. -5 divided by -1 would be positive 5. And again, I check, and I need to end up with the exact same terms there, that whole expression. Again, the same variables, the same constants, the same signs. They have to be identical to be the GCF. So now I take out that GCF of b plus 5, because they both had that in common. What's left when I take that out? I had an a and a -1. And there's the factored form. So when we have 4 terms, we group them into groups of 2. We look for the GCF of each group individually. we factor it out. We write it in the factored form of that GCF for that group, what was left when I factored it out, GCF of this group, what was left when I factored it out. And then if I did it right, I can also see a common binomial that I can factor out, and what's left once I factored it out, that is the factored form.